All right, good afternoon, and welcome to our second lecture on object-oriented programming. Today we're going to focus on reference types and other types, primarily in relation to how Java deals with these. But you will find that these principles are generally held by most true object-oriented programming languages. All right, so quickly, let us recap where we are, what we already know from our last lecture, or from the work that you were supposed to also do in our between our last class and now. So an object is an abstraction of some real identity, and we said that last week, that we can take something that exists in the real world and represent it on a computer, all right? And that generally is done by using a class, which is the blueprint for an object, and then we can create instances of that class, and of course, each instance becomes a separate object. And we did an example last week with a count, and we also looked at the data and the operations associated with that. So we also agree that an object is created by a process called instantiation, right? Now, noting here that an object is an instance of a class, and we use the keyword new in Java to create an object. We also know that object communicates through methods, and a constructor is a special method. We discussed that. Then we have two other types, which are accessors and mutators, which you can use to categorize the methods that you can write in your class. So today we're going to focus on explaining the differences between primitive data types and objects. We're going to look at what we call enumerated types, which is a special type in Java, and then we're going to look on wrapper classes, and wrapper classes become important in certain instances where primitive types are not good enough for use in such cases. All right. Now, so let's start by looking at reference types as primitive type versus primitive types, so that you can get an understanding as to what we're speaking about here. All right, so so far we looked at Java primitive types. We talked about int and double last week. We also spoke a little bit about character, and we're gonna tie that up. I showed you a table last week also that outlined these types, and I think we were pretty much good on that. We also showed you that a primitive type is declared in Java, and here's an example. Int count equal 0 is an example of creating a primitive type of type integer, which actually is also assign a value at the same time. Now, you will note that we can also create a primitive type without assigning it a value. All right? All right, so there's a difference, however, when you're creating objects, right? An object is a reference variable. Okay? Let's look again. The primitive type, int count equals 0, puts 0 into wherever count is actually located in memory. Double amount creates a location, right, which can hold a double, right, and it names it amount. Primitive types, that's how they work. Now, a class name, right, can be used to declare an object reference variable. Now, an object reference variable is declared to be an object, but it's not really an object, it's a reference to an object. Okay? Now, string, of course, string is an object, is built into Java. So we can use string, and the word title would create us a reference variable of type string. So it's referencing an object which is of type string. Now, if you were to attempt to do what you did on the previous slide, string is a special case, but in general, you would be able to do the assignment as we have it here in the case of how we do the assignment here, right? You wouldn't be able to do that, right? All right, so the variable is of type string. No object is created with this declaration. So we have not instantiated title. So there is no instance that exists. Only thing that exists now is title being a reference to a string, right? Now an object reference variable holds the address of the object. And so you have to now create the object itself separately. All right? Now, in Java, to create an object, you really need to use what we call a new operator. All right? So, that process is called instantiation, as I said many times before. And what you end up doing is really assigning the object type to an object. So, we did string title in the previous slide, right? So we have created a reference to an object of type string, and now we're actually instantiating that. Now what ends up happening when we use the new, notice what comes after it, after the object type, and then we pass in something inside of that function, and that is where we're actually calling the constructor. So remember when we talked about constructors last week, we said that the constructor is a special type of method that bears the name of the class, has no return type. So the new string is basically calling the constructor for the string class, right? And then of course, whatever is between the parentheses is what the parameters or the inputs to that constructor will be, right? In this case, it's a group of characters in double quotation, all right? So basically, we have now instantiated title, right? And now title has something in it, okay? So, yes, I just explained this. So title, it calls a string constructor to set up the object. And basically what ends up happening, as you see the line here, is that the title is pointing to a group of characters in memory. So let's say the first character is at position 1001, as you see there, right? So if that is the first character in memory, right? The rest of the characters, so this would be the memory address, right? And then this would be the second memory address, right? And this would be the third memory address. Notice each item in the string takes up a different memory location, for example. All right? Now, what ends up happening is that the setting up actually places the value into the address that was assigned to title when we did string title. Yes? And that address now, when you instantiate, that's when the values get put into the address that is assigned to string type. All right. Now, of course, the variable holds the address, which I just said, which is a reference. It's not the actual object. Question? All right. So, note that a primitive variable is a location in memory that contains the value itself. That's a primitive variable. Objects are different. So if I create a number called num1, right, the value is placed into that actual location. Now an object can be thought of a variable that stores a pointer or the address of another location. So if you go into name, you will find the address is stored in name to tell you where the object data is actually. So watch this. If you say, for example, print num, right? What is in num? 30, num1, thank you. 38. If I say print name, what is in name? No, an address to Steve Jobs. Right? Now, usually you have to now invoke some special mechanism in order to get the value out of it. Yes? Similar, right? But we'll get there, right? So then, in many cases, there is no difference between how a primitive data type is used and how a reference type is used. Objects can be used in many cases just like primitive data type, right? But an object can be used as a parameter or can be returned by a method and so on and so forth. So use is generally uniform. So if you have an int, right, like num1, you can use it the same way you can use an integer, which is an object type, and we're going to talk about it a little later, right? They can be used just the same, right? However, there are cases where the difference is significant. All right. So, for example, you can't assign one object to the other one the same way. Well, you can do the assignment by using equal, but the impact or what happens when you try to do that is different. Objects cannot be compared in the same manner as primitive types. Yes? I want you to look at something, right? If we say name 1 points to Steve Jobs, and we have name 2, right? And we have a picture of name 2 that is similar to this, and it's pointing to John Boehner, right? Yes? If we try and compare them, right? What would be happening is that it will be comparing if they are pointing to the same location. Because what are they comparing? The reference that is in the variable. Yes? So that's why we can't compare them the same. Yes? And we're going to do an example of that. So, the act of assignment, in general, takes a copy of the value and stores it in a variable. So, whatever is on the left gets put into the right. So, if we have in the case here, num1 being 38 and num2 being 96, and we put num1 into num2, then both of them now will have the same value, but they are different copies. So if I say print num1 or print num2, it's printing two different things. You follow that, right? Good. Because in num1 is the actual value. In num2 is the actual value. Why is that so? Because they are, as it says here, they are primitive types. Okay? Now, for object references, assignment copies the address or the pointer. So name 1 is pointing to Steve Jobs here. Yes? Yes? And name 2 is pointing to Steve Wozniak, right? Now if I compare, well, if I assign name 1 here, I say put name 1 into name 2, it doesn't copy the value. It copied the address that is in this into here so that both of them will have the same address. So it means that both of them will be pointing to the same object. Yes? So now if I say print me name 1, I get Steve Jobs. If I say print me name 2, I get Steve Jobs. If I change name 1 and print name 2, I'm going to see the change in name 2 because they are pointing to the same location. Okay? Now, it's very important that if I compare these two, they're going to be the same. Why? Because they're pointing to the same address. So the value in their address will be the same. because that's what is going to be compared. So that's fine. But if we have two different objects that we want to compare, obviously they're going to be stored in two different locations. So if I try to use the equal to compare them, it's going to look at the address, and the addresses are different. So even though they might have been the same values, it's going to tell me that it's different, because what I'll be comparing if I use the equal is the address of the object. Now, it therefore means we have to do comparisons with objects in a different way than using the equal. So usually we have to define a method that tells us how do we want to compare something. Let's say we have two accounts. How do we determine whether they are equal? We might have to write a method to say, okay, what it means for an account to be equal is if the account numbers are the same. Now that depends on the class itself. So we're not using the equal sign, we're using a method in the class to tell if the data in it represents what we consider equality to mean. In another situation where we're dealing with names, it might be the two names are the same, then they are equal. In another situation, it might mean if the two addresses are the same, if we're dealing with houses, we know it's the same house. So being equal can mean anything, but we usually have to define that. Yes? Separate for each class. All right. Moving on. Now, two or more references that refer to the same object are called aliases of each other. All right? It creates an interesting situation, right? So it means, therefore, we could actually create several variables that point to the same object. So basically, one object can be referenced by multiple variables. Because as in the case before, if we had said name 1 equal name 2, then name 1 equal name 3, right? And so on. I will keep assigning all of the objects that we assign will now be pointing to the same place. So any one of them will change. Huh? Yes. There would not be copies of it created. All right? Copying an object is also a different thing. Right? We'll talk about that a little bit later. So aliases can be useful, but you have to manage them carefully. And note that changing an object using one reference modifies it for all. So here's an example of aliases. Consider a class account which represents an account. And instance of account is, well, two instances are created, right? Two object variables are created, and then we instantiate one, right? ACCT, one equal new account, and we pass in 100. Remember, one of the constructors that we had last week, taking the initial balance, right? So building on that. So now we have our constructor, right, which has been invoked, and now we have created an instance here, which now has some value in it, because we have now used new to instantiate ACCT1, right? Yes? Now, that's what ends up happening. Now notice account 2 is not pointed anywhere, because we have not instantiated account 2. We only have said account 2 should be an object reference. But it's the object that it references has not yet been created. We created the object that is being referenced by account 1 when we did here say let it point to a new account, right? That we create here that's initialized. Yes? So ACC2 has no object that is pointing to it. Now consider the account class as three methods. Remember last week we had get balance, deposit, and withdraw. Right? Remember, get balance gives me back how much is in the account, so it returns me a double. Deposit don't return anything, it just added the amount that I pass in. And then withdraw takes away the amount that currently is in the balance and updates it, and it returns me the balance, right? That is left. Now, let us create ACCT2 object and make a deposit. Right? So we say ACCT2 is equal to $200, and we also call the deposit method on ACCT2. So now we say account 2 would have how much money now? Right. So account 2 has $300, right? Now, if we get the balance from account 1, it's 100 and 300 for account 2. Everybody happy? We didn't do anything but instantiate account 1 and put $100 in it. But we instantiate account 2 and we put $200 in there, then we deposit $100. Yes? Everybody happy so far? Now I take whatever is in account 1 and put it in account 2. What ends up happening? All of a sudden, I have lost whatever was in account 2. Because the reference in account 1 overrides the reference in account 2. So both of them are now linked or referencing the same object. What happens to what was in account 2? It's orphaned, right? There's no reference to it. Right? So it's in memory somewhere without a parent, wandering around. Now, account 2 is now an alias for account 1. Now, importantly, we're going to get back to what happens to that reference that has been orphaned, or that object that has been orphaned. Now, in comparing objects, as I said to you earlier, right, if we had 2 strings, for example, right, what we need to do is to I don't know how that. Oh, consider the following statements. All right, what is compared? I kind of told you that already here. Because I said to you that it's the reference that is going to be compared, right? The object references, and so that is not going to help. Objects are compared using a method named equals, so you can actually write a method called equals, which is the act of actually, well, every object has an equals method, and I'll talk a little bit about that when we look at inheritance and a little bit more about Java. So this method is defined for each class. It's defined for a string class to work by comparing strings, not the values of the object variables. When I show you the API documentation a little bit later, you'll understand what I mean. You will see that equals exist, and in general what you do is you will check one string equals to the other by saying, okay, if, as you see in the line here, if title1, which is the first object, then you say dot equals, and you pass in the second object here, yes, and then it's going to return you true if this equals method. Now this equals method is defined in the string class. Okay, and that's why you can invoke the method on a string. All right, and it returns true or false. And now equals would implement what it means for 2 strings to be equal. So maybe the way it does it, for example, right, it takes each character in the string, compare and see if they are the same, right? So the first compare the first, the second compare the second, and so on. And if it finds any difference, it returns false. Otherwise, it returns true, right? Now, that logic is defined. We don't have access to that logic. But in the same way, we can actually write an equals in our class with a logic that defines what it means for these 2 objects to be. Yes? Now, generally, the practice is that you use the equals method, because what that actually will do is that it will override the method that exists before, and I'll talk a little bit more about that in a future class, overriding and overloading. All right, you will learn how to write equals method later in this course, as it says. Now, when an object is no longer has any valid reference, like the case of account 2 that we overwrote account 1 with account 2, and so we lost whatever was in account. Sorry, it was the other way around. We lost one of them, and I told it's left. What happens is what we call garbage collection. And so Java has something called garbage collection that is built in, and it actually mops up all those objects that don't have any references left so that it can free up memory. All right? All programming languages tend to have this. People who program in more low-level language would generally have access to do it when they want. But in Java, you don't have access, so the programming language actually does garbage collection itself. Now, the unfortunate thing with that is you cannot tell it when to clean up. It cleans up when it feels like. Right? And sometimes you might be running something intensive. You don't want garbage collection to impact on your process throughput. And the system decides to do garbage collection. Right? If you're like a C programmer, you will find that annoying because in C you access memory, grab the amount that you ask for the amount that you want, take it, and when you finish with it, you give it back. Right? So a C programmer would be annoyed with automatic garbage collection. I'm somewhat of a C programmer, but that's a part of C that I really didn't like much. I prefer the system manage that, and I haven't come across any intensive applications that I've wrote that garbage collection has been an issue. But I know people have told me about their experiences, that they're trying to do some simulation that is processor intensive, and Java is doing garbage collection, and the process just stopped, and you can see it at the screen because it's graphical. You know, you see the program just stop, and you're like, oh my, it must be doing garbage collection, right? And that's kind of inconvenient. If you know, for example, was using something like C, then you could do your garbage collection at an appropriate time in your process cycle, like when you know you don't have as many threads or things running, you can do that in the back, right? So as I said, Java performs automatic garbage collection. All right. So I hope now you have an understanding of the difference between object references and primitive types and object, how they are handled in terms of doing your own programming. I'm going to introduce you to a few little variations of some of these things a little bit later, but that's the foundational knowledge. Now, built into Java are some special things that we're going to look at. Now, one of them is something called enumerated types, which you might like. Enumerated type is a special type that only stores values. It's generally a declaration which lists all the possible values a variable can take. And the quick thing that comes to mind is that in each year there are only 12 months, right? If I want to build an application that is going to be using date, right? Maybe I want to force the user to only be able to choose one of the valid months because they can't invent. Right? In a situation like that, what you'll end up doing is possibly using an enumerated type, which lists only 12 possibilities, which means that anything that the user puts in that is not associated with one of those 12, those are the only 12 values that are possible, right? So you can manage the inputs, or you can manage what is stored by using this type. So you can use identifiers of your own choosing, and an example is using season, where season can either be winter, spring, summer, or fall, and those are the only seasons, right? And you use the enum keyword, and then you give it a name. Generally, we use uppercase, as you see, season start with S, right? Because it's considered a class, so it's a special type. Any number of values can be listed, so it could be that. Another example where you could use enumerated types is countries, right? Although we know that political changes cause countries to increase and decrease over time and things, but it's not something that you want the user to be able to adjust in your application. So in general, that's the kind of use case we have for enumerated types. So once a type is defined, a variable of that type can be declared. So, for example, we define the type by using enum season and putting spring, summer, autumn, winter, or fall. And then we can say season, which is the name of the enumerated type, and time, and that creates an object reference. And then now we can assign a value, right? Notice the only values that can be assigned to time are those that fall into the list here of winter, spring, summer, and fall. Those are the only possibilities, right? That we can assign. Anything else you're going to get an error, right? Values are reference to the name of the type, right? Like you said, season.fall here, that assigns the value through reference to season, right? And that assigns it to time. And these are tend to be type safe. There's no way you can get the wrong value put in an enum type, right? So, for example, you might have a double, right? And you want the user to put in a value between 5 and 10, right? But really, you don't want to put in anything 5.45. You want him to round it up to 5.5 and so on. Yes? It's a double. If you're passing 5.45, then it's going to be accepted. Unless you actually write some code to ensure that those values are fixed. With enum, you won't be allowed to assign the value at all if it doesn't fall within the list. Yes? So there's no way to get the wrong data even in the variable. Right? And that's very useful because what that does for you, it reduces the need for you to write code to make sure you validate the input. Yes? You know only these possibilities exist. Right? And so you get an error if the user tries a different value. So each enumerated type is stored as an integer generally, and that's called the ordinal value. And the first value is 0, and the second is 1, and so on. Right? So you can also reference the values inside of the enum type by its ordinal value. Right? You cannot assign a numeric value to an enumerated type even if it corresponds. Right? You can only access what is at each so I was saying that enumerated type is a special type of class, and each variable of that type is an object, and the ordinal method returns the number associated with the value in the class, and the main method returns the identifier corresponding to the value. That's pretty straightforward, right? So you have an ordinal, I have a name. So you can say season.name, time.name, time.ordinal to kind of get back what the value or the name associated with that variable instance is. Right? The final thing in this lecture is really what we call wrapper classes. And there are many instances where we might want to be able to do some things and the primitive type is not good enough to be able to do that. All right? You might want to store a simple number in an object. And you might think, well, if it's an int or it's an integer, what big difference? Integer is the object type and int is the primitive type. What big difference does it make? But there's a simple example. So you know of arrays, right? An array is a sequence of contiguous locations in memory, similar to a list in Python. So the example is that we have what is called an array list in Java, which only allows you storing objects in it. So it means that if you have primitive types, you cannot store that primitive type in that array list. So what you end up having to do in such cases is to use the object type. Yes? I'm going to show you how you do that. Right. So, for example, Java has several classes that can be used to store a collection of items, and I was telling you, many of these structures are not do not store primitive types, so we have to wrap them in the object type. So, those object types generally are what we call wrapper classes. And so, for example, you will see here the primitive type byte has a wrapper class which starts with an uppercase B, BYTB. And for integer, for example, you have the word spelled out and a capital I. Okay? Those are the wrapper classes for the primitive types. So all primitive types, as you see here, have a class that we can use to actually wrap the primitive type into if we need the actual object type for some operation. All right? So for example, the following declaration creates an integer which has the value 40 in the integer object. An object of a wrapper class can be used in any situation where a primitive type belongs. And then primitive values could not be stored in such containers. I give an example, for example, with the array list. The other thing is that wrapper classes also contain what we call static methods. These are methods that can be invoked without creating an instance of that class. Yes, so you basically can use a class name and invoke the methods rather than having to create an object reference first, instantiate, and then use it, right? So this is something special. So integer contains a method to convert an integer storing a string into an int, right? So we could say, for example, integer.parseInt. And so if the user entered a string, so we ask the user to enter some value, we could accept that value as a string and then extract out of that string the numeric value and put it in an integer called num, which is what you see here. Which is a good practice, for example, if you're asking the user for certain input, because you don't want them to put in the wrong type and then the system never expects that type and then it throws an exception, and we'll talk about that a little bit. So you may want to collect it as a string and then see if what they put in is good. And if it's not, you tell them, right? Rather than having a type error and it throws what we call an exception. And they usually sometimes contain some constants that we can use. So like an integer class has min value and max value, which hold the smallest and largest integer values that are, right? There are just some concepts here. What we call auto-boxing is the automatic conversion of a primitive type to an object type using the wrapper class. And there's a way to do it pretty easily without all the fandangos. So for example, we have an integer object here, and then we have an integer num, and we set it to 42. Assigning the num to the object automatically boxes it into the integer. Yes? So basically, 42 goes into the integer object, right? So now the integer object has been updated. So what you realize here, you can assign a primitive to the object type and its type. Yeah, it takes the value. The assignment creates the appropriate integer object, which means that this object reference here now has been assigned a value. So there is now the instance in a sense. The reverse conversion is called unboxing, and it's automatically done, right? So if we have a double, which is the object type here, right? And we set it to 15.5, then we actually, oh yeah, this is just a quick check, sorry. It will be auto-box into a double object. Here, although what you would expect to see in this case is that you would say double value, and then value equal new double, and then you put the value in there. But by creating the object reference and assigning it, it automatically works, right? And the same thing happens for her. All right, any questions on that? All right, so we will take a quick break, and then we will resume with the part B of today. All right, so this is the second part of the lecture today. And what we will be looking at are three things. But in general, the Java API class library, which you absolutely can't program without if you're a Java programmer. We're going to look at a particular class in the class library. And then there might be a few others that are useful. But in general, I'm going to focus a little bit more on pointing you to some of the packages that you can go and look at. And it's always a good thing to go in the API documentation and just browse around to see what's there, right? So I'll also show you where to find that. And this probably be one of the most popular things on the web. I don't have to show you, but I mean, I'll do it honors anyway. All right, so we're going to talk about the Java API first. So in general, any Java program you write, and it's more so for almost every program that you write, you will have predefined code that you can reuse that comes as part of the language. You might have extensions that you can install and just reuse also, and Python have a lot of those. And then you will write the rest yourself. Right? It's the same thing for OOP. Reuse is one of the major advantages of OOP. And as you move further in your courses and you do more about design and so on, you will recognize that there are some principles that if you adhere to, you will end up writing. The more you code, the less code you probably tend to write, because what you've written before can be reused. You write it well one time, you can use it many times, right? So we need an object that stores appointments, for example. You can write a class to do this from scratch, or you can find a class that has already been written to do this. Like other OOP languages, Java has 100 of classes. And they are generally free, although I can't tell you that everything is free. But that's the philosophy of Java. Maybe some people have some packages that they have written and they want to resell, but all that we're going to show you are really free to use. A class library is a collection of classes we use when developing a program, and that's just theory. And Java has what is called a standard class library, and it comes as part of the development environment. Once you develop the Java development kit, you will get those. They are not a part of the Java language generally, but we rely on them heavily. So system and string are examples of classes that are part of what we call the standard library, and they are really right. Now, in general, most people call the Java library the API, which stands for Application Programming Interface. All right. Now, documentation is available for all the things that are in the API. And sometimes you will hear people refer to specific APIs, like a special set of packages called Swing and the database API or something. Right? So everything in the Java API are usually organized into packages, and a package in general is like a folder, right? When you're coding, that's really what a package comes down to. Right? And this can have subfolders and so on. And generally, you put a set of things in a folder that are related, just like how you're organizing files on the phone. Right? There are some examples of packages here. Java Lang is a default package, and it's for general support. You have the applet, AWT, Swing, .NET, Util, XML parsers, and so on and so forth. And they have their different uses. And in general, once you start learning which classes you want to use, you will also learn which package they belong to. And that means that you can now import those packages or use what we call a fully qualified name to utilize them. Right? And this is just some examples of which classes are in which packages, yes, and what they're doing. That's where you can read, right? And there are many others. Now, in utilizing what is built in the API, you have two options really. Well, maybe some people will say three. You could use a fully quantified name. So, for example, you could say java.util.scanner, and then you say P, and then you say P equal new java.util.scanner. Right? And you open bracket, close bracket, and you pass it. Or you can import the class and then use it. So if you import it, like we have import java.util.scanner here, then you can just use the word scanner, right? And it knows what. Right? Or you can import the entire package by using the wildcard stars you see here, right? So in here you see we use the wildcard star right here, right? To mean everything in the java.util package, right? In the case above, we only want the scanner class out of the java.util package here. See that? So everything in the util is going to be imported in the case you're using wildcard, and this just the scanner class from the util package will be imported where you put the dots. Right? You can decide. Because sometimes there's a package that you're going to be using multiple classes from. Instead of importing them one by one and have 10 import statements, you just say java that, for example, .util.star. And maybe that package had 11 classes. You're only using 10 of them. I mean, you don't lose anything for importing that additional one. And if you don't use it, it doesn't create a problem anyway. Now, it is important to know that all programs automatically import the java.lang, so you don't have to do it yourself. All right. So you can assume that the statement java import java.lang star, basically this statement, you can assume that that statement is a part of every program that you write. Right? So anything that belongs to the lang package, you can use for free. Right? So that is the reason why you don't need to import the system or the string classes explicitly. They're built in. They're automatically imported into any program that you write. Yes? So first thing to do probably is to learn which classes belong to java.lang and to know that you okay for these classes, they don't need an import statement. Right? They're automated. Yeah. Generally, right? So you can assume that that statement is a part of every program that you run. So you don't have to do it. So anything in java.lang, you're fine. You just use it. Now the scanner class, however, is part of the java.util package, so you have to import it manually. Now, we know that the string class we use to create a string object to represent a string of characters. We also know the string class is in the java.lang package. I don't need to import it. The interesting thing is that because string is so popular, there are some variations in how we can actually use it. So for example, we don't need to use a new operator to create a string, for example. So we can just say title equal Java software solutions. Notice we didn't write the word string or anything. That will just work. Just because it's a string. Okay? The other interesting thing is that, well, this is just a special syntax that works only for string. The other interesting thing that you might be happy to learn is that, let's say we want to print out, we have a string and we want to print out uppercase version of it, right? We can actually just say, we can actually just write the string. We can actually just do like this. Put the string in quotation, some string, and use the dot operator and say to uppercase. Now, I know I don't write so well, but you would notice that I did not create even a variable to do that, right? I just put a string in quotations and use the dot operator and invoke some method on that string. What that is going to do is to translate all the characters in the string to an uppercase. No, I don't store it into anything. You realize that? Yes? But I could always do something like, let's see. I could just put that in bracket. Put that in bracket and do something like a system dot out dot print. Right? And call the system dot out dot print, and what it will do is print out the uppercase version of some string. All right? So strings, versatile. Yeah? All right. Each string literal enclosed in double quotes represents a string object, which is what I just basically demonstrated. Okay. Special case just for strings. All right. Some methods that you might find useful, and I think you might want to pay attention. Of course, you can read and find out other methods. There are a lot like to uppercase, which converts a string to uppercase, but does modify the string itself. A string in general are immutable, right? What that means is that the actual string is not modified, but the modified version has to be put in another object. There are few methods that allow you to modify the body of the string, right? So you have to pay attention. So that returns a string with characters converted to uppercase. Replace, return string with characters C1 converted to C2. Replace all occurrences of A with B, for example. Storing some string into a string. Concatenate two strings, right? And there are many others. Once a string object has been created, either its value or its length can be changed. Therefore, we say that an object of a string class is immutable. However, several methods in the string class, as I just said, return a new string object that are modified versions of the original. So the original string usually is not ever modified. All right? And a string can be indexed, each character. You can actually identify each character in the string. So, and strings are indexed on 0. So, for example, in this case, in hello, you would assume that the H here is at index 0, and the O here would be at index 4. Good. And there's a string notation set of code here that demonstrates something that can be done with strings. So for example, we realize that here we create a string phrase. All right, now we assign changes inevitable to that. And then we create some object references, right? Mutation 1, 2, and 3, 1, 2, 3, and 4. And then what we do here is to print out the original string, which is phrase, right? And the length of phrase, right? String dot phrase dot length gives me back the length of that particular string. Now, mutation 1 is whatever was in phrase, which is what? What is in phrase? Change is inevitable, right? And then we concatenate that, which means we join the comma and except for vending machines. Okay? Then what we do with mutation 1, we change that to uppercase and put it in mutation 2. You see that? Then we replace all the E's in mutation 2 with X. Then we take the substring from position 3 to position 30 of mutation 3 and put it in mutation 4. All right? You will spend a little bit more time playing around with that, right? And then we print out all of them, right? Along with the length of mutation 4. And as you would see here, the original string is changes inevitable, the length is 20. Then mutation 1, 2, 3, and 4, removing the E's and then replacing them with X, and then taking out the different parts. Now, that's just an example of what you can do with strings. It's not meant to be exhaustive. Okay? So here's another example that I want to use as a quick check. Let's say we have a string str that is assigned space defined on the frontier. What would I get from str.length? Yes, which is what will be printed out? Okay. Substring 7, what would I get? Huh?
Space. You get space in the column.
And to uppercase, not telling you if you're right or wrong. And then str length. Having done all of that. Yes, after doing all of that, what would I get to str length? Strings are muted, remember? Yeah. Same 26. Yeah. So the string has not been modified by any of those. The only way str would have been different is if we take what str dot one of those methods produce and put it back in str, which is to overwrite the original.
Substring 1.
It starts at position 7.
Oh, start.
Yes.
Oh,
the substring from position 7 to the end. If you put another value in there, it stops at that value. So in the first case, it was 3 to 30, so it starts at 3 and it stops at. I remember it's 0 index. Yeah. So 3 is really actually position 4. Now, with all that I explained to you, the best place to go is the API documentation, right? Which you can find at docs.oracle and all of that you see there. Your best friend. Now, you don't have to worry about trying to remember the name. If you go to Google and type Java API documentation, you must get the link, maybe the first or second link that comes up. It's that popular, right? Everybody search for it every day, right? It's a big hit. And the important thing to note is that the version that you're reading refers to the version of Java that you're using. And Java 8 is really 1.8. Right? You just use the digit that comes after the 1. So whichever version you download, which I think should be 8, but some people have 7, you will read that. And there are a few minor things that will change from version to version. Importantly, you have to learn how to navigate the documentation, right? Things you want to know, constructors and their parameters, methods, their return types and parameters. So when you go, like for example, in the string, in the Java lang package, and you see the string class, and you click on string, what you will see is a list of all the methods, what the constructors are, what they take in and what they return. Once you know what they take in and what they return, right, and their name, you can use them, right? And then you can read a little detail. You know, some have more detail than others about how they might do some of the things that they do, right? And so when you read well, you will be able to use the Java language well, right? So every Java programmer tends to have the API documentation open while they're coding, because you always have to consult to see, okay, You might remember that string has a two uppercase, but you don't know exactly what it takes in, what it returns, and so on. And so you need to go back to the API document. You know it's there, you know how to use it, but you want to make sure. Yes? And also know that even with a method, there may be several versions of the same method. So it might have the same name, but the parameters are different. The return types are different, and so on. So not because the name is there, it is the parameter and that it takes in and what it returns that is most important to you. Because yes, you want to get a string out of this variable, right? But it takes in a double, so it's the wrong version. Or you want to get a string out of this variable, right? But it takes in an int. Yes, so you have to make sure which version of the method you're using. Sometimes they carry the same name, sometimes they have different names. The moral of the story is that make sure you read the documentation and be happy ever after. Alright, so we talked a little bit about the string class, which I showed you where to find more information. I'm going to focus a little bit on one class that you're going to use more than your fair share. It's the primary class we tend to use to accept input from the user because it's so easy. And it's called a scanner, right? A scanner object is used to do to manage input data to program, and it's easily done by creating a scanner object and instantiating it with the what we call the system input stream, which allows it to collect data from your keyboard. Okay. Now, this creates an object that accepts data from the keyboard, and the Java system.in is automatically created, just as the system.in. The scanner class has some useful methods, which you will also read in the API documentation. Things like next and nextInt and double. And as you will see here, when you see string next, what does that mean? String next means it returns a string. NextInt means that it returns a. So if I wanted to use nextInt, right, and I have a scanner, if I have a scanner S, I would say S dot next int, right, and I call that. That is going to return me an integer. So I need a place to put that because this is going to evaluate to a value. So I probably need an int p to say equal, right? So whatever this returns goes into p. Then I can now use p. Yeah? Happy? So that's why you want to know the return type. Next double same thing. Next line, you know you're getting back a string object. Right? Has next, you know you're getting back a boolean, true or false. Right? So when you know these things, you know how to use. You know what it takes in? Nothing. You know that you have to have a scanner object, however, in order to use it. Right? Now, here's an example of that. As I said earlier, where I create three integers here, int A, B, and C, and then I create a scanner called input here, and then I instantiate that with the system input, right? And then I print out a number, and then whatever the integer is that I took in a while ago, right? I call nextInt on input and put it in A, right? And I did the same thing for B. Then I add A and B and I print out the value. Now, white spaces don't generally matter, but you know, it doesn't look good and might not be appropriate. Now, the math class is a part of the Java Lang package, right? And this is one of them that you really don't need an instance of the class to invoke the methods, right? It's more, it has several static methods that you can use by using the class. Yes? So the math class contains methods that perform various fundamental functions. And these include like, you know, square root, exponentiation, and so on. And here's an example where we can say for example, here, math.cosine, or math.cos, sorry, right? Notice we didn't create an instance here, right? We just use the name of the class, math, the dot cosine, and pass in 90, and we add that to math.sqrt with some value delta, or some variable, sorry, delta. Notice we didn't create any instance of math by saying anything like math x, and then say x dot cos. Yes? That's not necessary. All right? So, as you realize here, this is a situation where some of these things become like a utility. And instead of having to create an object, we just use the class followed by method. And you might find that in writing your own code, there might be some methods that you want to be able to use that without instantiating an object. And that is a design decision. We'll discuss that. And so here's an example again, where we create three doubles, A, B, and H. We accept some input from the user, right? And then we put it in A, we put that in B, and then we square here that value. So we use math.square root in our code here, right? And math.power, which takes in, power basically takes in two values and raise the first one to the value of the second, right? And so basically this is going to be b squared and a squared, and then you find the square root of all of that, and that will give you the hypotenuse, given that you get the valid values for A and B. Question? All right. There are some other cool classes like random format, you know, and if there is ever something that you don't know, you'll be happy to know that a search will yield you the results. So, for example, you know, typing in something like Java class for dates, you'll get a lot of documentation available that will help you. And one of the links is sure to point you to the Java API documentation that you can. Yeah. That's about what we have to cover today. I don't know if you have any particular questions that I might be able to assist you with. Yes?
For your own, like, the right program here. We will do like this.
Oh, when you write the program in the actual IDE, there is a button there that allows you to run. Now, please note that it won't run unless you have a class which has a main method, which the compiler is really looking for the main method to invoke. So you can't run a class that doesn't have a main method. So you have to create the main method, which we call the driver, and then that main method must now use the other classes that you would like to test. And then that is where you determine whether or not the class is working. The truth is that you can write a main method in any class, but that's not a design principle that we suggest. We always suggest you have a class that is designated your driver class, which only has the main method and nothing else, right? And then that class is what you use now to reference the other things that you need. And it basically controls the sequence of how things ought to be done in your program, all right. I think that ends it for us today. And Barbados, I'll take your questions via email possibly. All right, thank you.